Hello, boys and girls. It's Mr. Malsberger here. If you listen to that wonderful sound in the background, you'll hear my dishwasher running. I did not plan ahead. I was like, oh, I need to record a video. Let's pick up some things in the kitchen and run the dishes. And now as I sit here, I go, oh. But that's okay. So we'll have some white noise in the background as we talk about imperfect squares. This is this is unit 7, lesson 3, right? So of course, perfect squares, we already know. Perfect squares are when you take a whole number and you double it. 3 squared is 9. That is a perfect square, right? Imperfect squares, it's not really when you square them, because any number you square becomes a perfect square, right? So even if I did 2.5, you're like, well, it's not perfect because it's a decimal, but when I square it and I get 6.25, it's still pretty perfect. Imperfect squares are when we take the square root of a number, let's say 18, right? It's not a perfect square. So its answer is going to be an irrational number. If you remember irrational numbers, we first started talking about them when we talked about the pi. Pi, 3.141592, on and on and on forever, is an irrational number because it never repeats, and the decimal is non-terminating. Well, square root of 18, same thing. It's not a perfect square, and so its answer is going to be positive or negative, some number, point, ... tons of different numbers after there. So what we're going to do is we're going to learn how to do two different things today. We're going to learn how to estimate, and then we're going to learn how to simplify. Now, simplifying is the one I'm really going to test you on because it's pretty straightforward. Estimating is, I just want to show you kind of how you can estimate it, but why would you ever when you just do square root of 18 on your calculator and know that it's 4 point something? So let me show you what I mean. First thing we need to look at is you need a perfect square chart from 10 down to 1, and I'll show you why. 5, 4, can you see all this? Yes, you can. 3, 2 squared, and then who cares about the 1 squared? So we get 100, 81, 64, 49, 36, 25, 16, 9, and 4, and then 1 for the last one, correct? Oops, can't see the 1. Okay, so here's what we're going to do for estimating. So we're going to look at the number that we're taking the root of, the square root of 18. And what we look for is where does 18 fall in this number line? Because there's gaps, right? In between 64 and 81, a whole bunch of numbers are there. Well, we're looking at 18, which falls right here between 16 and 25. Now, the reason I said it is 4 point something, because when you find where the number falls, you go down, and that's your whole number. It's 4 point something. 4 times 4 is going to get us 16. So 4.1 or 4.2, whatever it's going to be, it's going to be a never-ending stream of decimals, will get us closer to 18. Now, the decimal, we're not really going to find a decimal. We're going to find a fraction, which of course can give us a decimal. Now, here's how you do that. The fraction has to do with the space between these numbers here. So the denominator is the difference between the perfect squares. So for this one, it's going to be 25 minus 16. Is how many numbers are between them? Well, that's 9, right? Cool thing is if you look, the two perfect squares is 4 squared and 5 squared. 5 plus 4 is 9. And so the difference between the two perfect squares is 9. If you looked at 64 and 49, 7 plus 8 is 15. Guess what the difference between 64 and 49 is? It's 15. This pattern is never failing, like everything in math. The distance between two perfect squares is always the sum of the two root bases, right? When you add them together. So if we were looking at 24 squared to 25 squared, well, that's gonna be, they're gonna be, what, 49 apart. Anyway, so this is the denominator, the distance between the two perfect squares. Now the numerator is the distance from the number we're looking at, 18, and of course the lower number. We're gonna subtract always the lower one. And that gets us 2. So this one, the square root of 18, is gonna be positive or negative 4 and 2/9. So I only really need you to find this. Like if we took the decimal, 2 divided by 9 is 0.222222. So basically, the square root of 18 is basically 4.222 forever. Now watch, if I take the actual square root of 18, it's not gonna be perfect. It's 4.2426, it goes on and on and on. But you see how that's pretty darn close? I mean, if I took 4.222 and squared it, getting pretty darn close to 18, 17.8, right? So it's not exact, it's an estimate. That's why we say estimate. Let's do another one. So let's find the square root of, say, I don't know, let's do, 30 sounds good, okay? So if you want to stop, pause it, and try it yourself, you can. If not, let's see. 30 falls right up in the next little notch between 25 and 26. 25 and 36, excuse me. So I know that the whole number is going to be 5, right? 5 squared is 25, 30 is above 25 but below 36. Now let's look at the fraction, okay? The difference between 36 and 25 is the same as the sum of 5 and 6. So the denominator for this is going to be 11. Now we're looking at 30 and that lower perfect square. 30 minus 25 is what? 5. So 5 and 5/11. It kind of looks like a decimal point there. I kind of set my pen down. Sorry, it's not what I meant to do. If you divide 5 by 11, you get 0.45454545. So you don't have to do the decimal. I will accept the fraction because it's more exact, really. But let's see what the actual answer is. See how close our estimate is. The square root of 30 is, look how much closer this one is, 5.47. So we're a little above this time, right? But, or no, we're below, dummy. We're below, but we're much closer. With the 2/9, you know, we were in the 10th place, we were off. This one, we're off in the 100th place. And as you go up higher and higher, the estimates that you can create become far closer to the actual answer. Because down here, there's not many numbers to make more exact fractions. 2/9 is small compared to if we looked at the square root of, let's say, 92, okay? This is gonna be much bigger than this, or not bigger, closer to the actual square root than, say, the square root of 18 because it's small. If you're looking at the square root of 640, it's going to be even closer because it's such a bigger number. Your fractions are going to be more closely set to the exact number. So the square root of 92 falls right here between 10 squared and 9 squared, 81 and 100, right? So you looked at the lower perfect square's root, 9. So this is going to be positive or negative 9. Let's create the fraction. The difference between 181 is 10 plus 9, 19, right? Now we subtract the 92 from the lower perfect square. 92 minus 81 is 11. So if you got positive negative 9 and 11/19, you're pretty darn close. I will accept that. That is a great answer. Let's divide 11 by 19, and we get, so 9.5789, right? Let's look at the actual square root, just so we can see how close we were. Look at that. 959, 958. You know, if we rounded that up, that's pretty, is getting closer and closer. So this is the basic estimation, right? Let's do one more and then I'll show you what simplifying looks like and then we'll do a little practice. Let's do the square root. By the way, ones you're gonna have to do are just gonna be between 1 and 10. I'll do one that's a little bit higher. Let's do 160, right? Now, of course, having a perfect square chart makes all of this easier. I know that 144 is 12 squared, right? And I know 13 squared is 169 because I've memorized these things. So the whole number is going to be 12. My denominator is going to be the sum of these two roots because 169 minus 144 is 25. So I did it again. I put that dot there. I keep tapping it like it's a decimal. Now to find the numerator is 160 minus the lower perfect square. So 160 minus 144 is 16. Right? So 16 divided by 25. You don't have to do the decimal. It's 0.64. So I've got positive or negative 12.64. Let's see what the actual answer is just for fun, because I'm always curious how close we are. 12.64, and then there's a 9. See, now we're only off in the hundredths. That's how much closer the estimates become. Okay, so this is one type. You're gonna do a couple practices with these in a little bit, and sure, I'll throw one on the test, but you should be able to go back to this lesson and figure this out. So if you're making like notes right now, what I would do is I would start like putting things in order, lesson 1, lesson 2, lesson 3, and take the important pieces out so you have a little guide for when you get to the test. Of course, you can do the review and all that, but I'd pretty much put things in order. I'm kind of nice like that. All right, so now let's simplify. This is different. Instead of trying to get an exact or a close estimate like we did before with a whole number and a fraction, we're just going to make the square roots smaller. I'll show you what I mean. First thing I want to have is that perfect square chart again. I should have just made one and kept it for the whole thing, but 3 squared, I didn't. 2 squared and 1 squared. Aren't I a lovely writer here? 25, 36, 49, 64, 81, and 100. Now we're not going to fall in between these things. What we're going to do is we're going to look for perfect squares as factors of the number we are taking the root of. So if I had to take the square root of, let's say, 24, what we're looking for is factors of 24. Now, if you remember 24 factor charts back in the old days, you do a little tree. You're like, okay, I can divide it by 2, and that becomes 12. I divide the 12 by 2, and that becomes 6. And I divide by 2 again, and I get 3. That's a prime number. These are the factors: 2 times 2 times 2 times 3. Now, that is the full factor tree. I don't want you to do that, because it's not what I want you to look for. What I want you to look for are I didn't make my 4 very nice right there. I want you to look for perfect squares as factors of the number that we are taking the root of. So right here we say, well, 24 has a 4 in it because this is 4 times 6, right? Those are the factors of 24. Since 4 is a perfect square, what we can do is take it out from underneath the radical sign. So what's the square root of 4? It's 2. So I'm going to put the 2 on the outside. It's still going to be touching the radical because it's going to be multiplying whatever the square root of 6 is. 6 is not a perfect square. It's made of 2 primes, 3 and 2, so I can't reduce it anymore. Of course, this would be positive or negative because we still don't know. This is the simplified version. all you're doing is pulling out perfect squares, taking their roots and plopping them in front of the radical sign. So let's see, if I take the square root of 40, right? This one should be very similar. We know that 40 is 4 times 10, correct? That's the easiest way. Now, of course, you could have done 8 times 5. If you did 8 times 5, you'd say, well, neither 8 nor 5 are perfect squares, and you would then divide the 8 into 2 and 4, and there's your perfect square of 4. The square root of 4 is 2. 10 is built of 2 and 5. Neither are perfect squares, so the 10 stays in there. You can put the plus and minus if you want. I really don't care that much right now. Let's do another one. Let's do the square root of 150. Okay? Now, 150, maybe you say, well, that's 3 times 50. Is there a 4 in there? No. A 9? Definitely not. A 16? I don't see a 16 in there, but I know there's a 25. So this splits into 2 and 25, right? Now this is the tricky part. These ones were just little two-steppers, but check this one out. 25 is the perfect square. We're going to take the square root, which is 5. What's left inside, though? Is it just the 2? It's the 3 and the 2. Now, there is a way to check this. I'll show you. So, to check your answers, you take the number on the outside, square it, multiply it by the number on the inside, and see if it matches. 2 squared is 4, 4 times 6 is 24. 2 squared is 4, 4 times 10 is 40. 5 squared is 25. 25 times 6, 6 quarters is $1.50, so there we go. Making sense? Maybe. Okay, let's take the square root of, let's say, 63. So 63 is one of those numbers that I'm sure you know. There's only a couple ways to make it. 3 times 21 or 9 times 7, correct? So we're looking for perfect squares. So we're looking for a 4, a 9, a 16, and a 25. 9 times 7 is 63. The square root of 9 is 3. So this is 3 times the square root of 7, positive or negative, of course. To check, 3 squared is 9. 9 times 7 is 63. That's all we're doing is simplifying. Now what I would like you to do is look at your imperfect square practice sheet, okay? We've got 1, 2, and 3. You're estimating the root. So use your perfect square chart. Find out where 18 and 30 and 58 fall in the perfect square chart of 2 through 10, and give me the whole number in a fraction. Simplifying the root is what we just did, so I should have some number times the square root of some number that you can't pull anything else out of, all right? Pause it and we'll go over it. Okay, we're back. Let's take a look. So we're estimating the roots. Now, I'm just gonna write on the side. Should have just kept it. Oh, look, here, I'll just do this. I won't waste your time. I'm just gonna use that perfect square chart again instead of rewriting it. Okay, so we're looking at 18. Wow, I'm hilarious. I gave you that one as an example in the actual work. I didn't even look at it. I just pulled that one out of my head, but it makes perfect sense. Okay, so 18 falls right here, right, between the 25 and the 16. So I know it's gonna start with a 4, because 4 times 4 is 16, and that's smaller than 18. To find the denominator, I'm going to subtract or add these two. So 25 minus 16 is 9. 5 plus 4 is 9. There's my denominator. And 18 minus the lower perfect square, right? 18 minus 16 is 2. You can leave it right there. If you wanted to go farther and did positive or negative 4.22 with a bar over it, that's a good estimation. Whew. I'm a dum-dum and gave you this one too. Well, either that or I'm just really nice. Here we go. 30 is going to fall right here between 5 and 6. So its whole number is 5 because that's the lower perfect root. The distance between is 36 minus 25, which is 11, or 6 plus 5, 11. And then 30 is 5 greater than 25, so my numerator is 5. Leave it like this, you're good to go. If you did positive or negative 5.45 with a bar, you are correct as well. Number 3, 58. 58 falls right between the 7 and 8, 49 and 64, right? So 7 is the lower one, that's my whole number. Now I need to find the difference between 64 and 49. Well, that's just 8 plus 7, 15. And now what's 58 minus 49? 1 makes it 50 plus 8, that's 9 over 15, which simplifies down to 3 over 5. So like 7.6 is that one as a decimal. This is fine, you don't even have to give me the decimal. And curious me, I'm going to see how close we, no. How close are we with this 58? 7.615, yeah, see? We're only like a 10th off, or a 100th off. Pretty good, 15 thousandths off. All right, simplifying the root. All right, let's slide this up. I will keep this chart because it makes it easier. 18 again. Well, I'm looking for perfect squares. I know that's 9 times 2, right? 9 is a perfect square. Its root is 3. So I have positive or negative 3. What's left inside is the 2. Number 5, 54. Well, 54, of course, is an even number. I could split it in half, but I know this as a math fact is 9 times 6. Remember, your goal isn't just to factor this. That's kind of wasting effort. What you should really be doing is thinking about, can I divide it by 4 or 9 or 16 or 25? I guarantee every problem I give you will have these core perfect squares in them. And if I'm keeping it to numbers no higher than 180 or something like that, you'll see that it's all these. This is what we're looking for. So square root of 9 is 3. So positive or negative 3. 6, can't get anything out of it because it's just 2 times 3. Leave it on the inside. 6, 50. Well, I can't divide it by 4, 9, or 16, but I can divide it by 25. This is 25 times 2. The square root of 25 is 5. And I leave that 2 on the inside. Correct? Last 3, here we go. 24 is 4 times 6. There's my perfect square of 4, so 2 goes on the outside. 6 stays on the inside, and it's both positive and negative when it's ever figured out. 63, well, that's a math fact I know, and there's my perfect square of 9. 9 times 7. Take the square root of 9, and I get 3. That's positive or negative 3 times the square root of 7. All right, here we go. 180. Well, right now I think, well, this is like 18, so there's a 9, but instead of times 2, it's times 20, right? Now check this one out. 20 can be broken up again into 4 and 5. So I've got the perfect square 9 and the perfect square 4. What is 9 times 4? It's 36, and the square root of 36 is 6. So 6 is what's going to go on the outside. You could also get that by saying square root of 9 is 3, square root of 4 is 2, and so 3 and a 2 make it out, and everything gets multiplied. 3 times 2 is 6. The 5 is the only thing left. And there is the answers you are looking for. Hopefully this makes sense. You're probably like, when am I ever going to need this in my real life? And I'll say, don't know. But you can get credit for this and prove that you're smart and able to figure out strange patterns in math. Hope you guys are doing well, and I'll talk to you soon.